All right, let's go over the example problems. So in this one it says a wave generator produces straight parallel wave fronts in a shallow tank of uniform depth water. Now the water is our medium and the water is not changing. Now if the water doesn't change, therefore the medium doesn't change, therefore the speed of the waves does not change. It says the frequency of the vibration increases, which characteristic of the wave must decrease. So if the medium stays the same, V stays the same. So we have V equals F lambda. The V is the same. F is going up, so lambda, the wavelength, must go down. In this one, it says a student claps his hands once to produce a loud sound wave. Okay, so that's the key right there. And it asks us what type of wave is this sound wave. Sound waves are mechanical and longitudinal. So that's our answer. You just have to memorize that that's the type of wave that it is. And in this last one, it says students generate water waves in a pool of water to increase the energy. Well, energy in a wave is the amplitude. Amplitude is directly proportional to the energy. So that's our answer, greater amplitude. Okay, I made a mistake on this one. This is actually covered in Waves Part 2, but let's go over it anyway. We have a diagram of some waves, and it's called a standing wave. It's a certain type of wave that appears as though it's not moving, but there is a velocity to it. And the points on the wave that stand still are called nodes. So these are our nodes. And there are 4 nodes in this wave. And the part that's moving the most is called the antinode. So there are 1, 2, 3 antinodes in this wave. In this one, this is the principle of superposition. We have these 2 waves approaching each other. So what I did was I laid this wave over the top of the other one. So you can see that this and this will cancel each other out. So that'll be no amplitude at that point. This amplitude plus 0 is just going to be that. And this amplitude plus this is just going to be this value up here. So the answer is 1. Okay, there's a lot going on in this question. We've got a wave in a uniform medium. They give us the amplitude is 0.2 meters. The wavelength is 0.4 meters and the frequency is 10 hertz. They want us to draw this wave. So the wavelength is 0.4 meters. So we need to draw one full wave in 0.4 meters, but the amplitude is 0.2. So that's going to be 0.2 up and 0.2 down. In number 7, it says calculate the speed of the wave. Well, they gave us the frequency and they gave us the wavelength. So it's just V equals F lambda to get 4 meters per second. And lastly, they said determine the period of the wave. Well, we know the frequency is 10 hertz, so we just solve t equals 1 over f, cross multiply, solve for t, and t is 0.1 seconds. What happens after 2 waves interfere with each other? Well, what happens during the interference, we get superposition, but after the interference, they just move on their way, so there's nothing that has changed. And this question is one more question that I should have put in the Waves Part 2 unit. This phenomenon that happens when soldiers march across a road, they start to step, and if they step simultaneously, the bridge will start to vibrate, and that phenomenon is known as resonance, and like I said, we'll get into that in the Waves 2 unit.